wabarakatuh. So today I'm going to explain to you how we want to interpret the UVVs and FTIR spectra. Okay, first of all we will start with the UVVs. Okay, for the UVVs, in order we want to interpret the spectra, we need to find out what kind of the transition that will be present in our molecule. So the transition that can occur or that can present in our molecule will be the pi to the pi anti-bonding and the non-bonding to the pi anti-bonding. So we need to compare these two transitions in order we want to determine its wavelength. So the electron in the non-bonding orbital are higher energy than electron in the bonding pi orbital. Okay, so here the transition from the non-bonding to the empty pi anti-bonding orbital will be required less energy than the transition from the bonding pi orbital to the empty pi anti-bonding orbital. Okay, so according to the Planck relation, we will have the energy equal to hc over lambda. So our conclude is if the energy is less, so our wavelength will be higher. Okay, from here we can conclude that the lambda max at the 295 nanometer will be correspond to the non-bonding to pi anti-bonding transition because its transition will be required less energy than the other one. Okay, and then the lambda max at the 195 nanometer will be correspond to the pi to pi anti-bonding transition. Okay, for our acetone, we can conclude that the lambda max for the acetone is at 295, which is the number or the higher lambda max that we can that the acetone can absorb. For the FTIR, we need to know what kind of the information that the FTIR spectra give to us. Okay, so FTIR spectra will be provide us the stretch or the bending that are present or the functional group that are present in our molecule. So for FTIR, the functional group, the stretching and the bending in the molecule will be absorbed at certain wavelength and give the transmittant. Okay, so we will analyze the FTIR first based on the frequency or based on the wavelength that the functional group or the stretch and bend absorb. Okay, first near to the 3000s is the, we can say that this peak is belong to the CHSP3 stretching because it's below to the 3000 or around the 3000s, and then around the 1700 is the, we can say that is the C double bond stretch because C double bond stretch is usually present at the wavelength between the 1750 to the 1680, and then around the 1500 we can say that this peak will be belong to the CH2 bending because CH2 bending is usually will be present at the 1600 to 1400, and then the peak here will be belong to the CC stretching because CC stretching usually will be present around the 1200, and the last one, the peak here will be present at for the CC bending, which is will be present around the 1100.